speak to me at the end. This is going to be live. Sorry, I'm going to put this on YouTube, so you can watch this back. At the end of this lesson, there is going to be a challenge for you to email me the answers. Okay. Once that's done on Thursday's lesson is going to be very much going through the answer. I'm going to show you another worked example of an algorithm, and then I have created a Microsoft Forms for you guys to complete in that hour. I will be online. I will have my Teams set up like this, so you guys can actually talk to me and ask me for any help as you go through the task. So let's get started. Okay, so here we go. So algorithms. I've just got a little video to show you just to start off with from the fantastic Craig and Dave. So just listening.
Understanding how to write and follow algorithms is one of those statements which appears in many exam specifications, as it is an essential skill. However, it is certainly not something which can be learned and mastered from watching one video. This video
Whoops. Sorry.
demystify what is meant by the term algorithm and give some examples of how you could produce them. It is suggested that you practice producing algorithms in whichever form you feel comfortable as part of an ongoing practical programming course. So what exactly is an algorithm? In its simplest form, an algorithm is simply the logical steps needed to solve a given problem. You can express an algorithm in any way you see fit, although popular ways to write them down are in the forms of pseudocode and flowcharts. Solving any problem, no matter how simple or complex, requires breaking down the problem into smaller subproblems and identifying the logical steps needed to solve them. The method that you come up with is your algorithm. The only thing that will make your algorithm for solving a problem different to someone else's will be the efficiency with which it tackles the task. Is your algorithm smarter? Will it solve the problem in less steps? Is it more robust? Would it work under all situations? The more you practice, the better you will get at producing smarter algorithms for solving problems. Let's have a look at a very easy and typical scenario for producing an algorithm. Let's look at the problem of making a cup of tea. This can be broken down into a number of steps, which have to happen in a certain order. For example, water needs to be boiled before it can be added to the cup. The water needs to be added to the kettle before it can be boiled. There are also possible decision points. Does the person want sugar? Do they want milk? Some steps could be done concurrently to speed up the process. While the water is in the kettle boiling, the tea bag and sugar could be added to the cup. What we're doing here is applying the principles of computational thinking, such as thinking ahead, thinking logically, and thinking concurrently. And we're using these processes to come up with a set of steps which will be our algorithm for making a cup of tea. Whatever set of steps you come up with, and however you choose to express them, you will have produced an algorithm. Here is one possible solution in the form of an algorithm for making a cup of tea. Here we've expressed it as a flowchart. Pause the video and spend a couple of minutes studying it. Here is the exact same algorithm. This time it's been expressed though using pseudocode. Under exam conditions, you can use whatever method you like to express an algorithm. However, do be aware of exam questions which explicitly state, for example, using a flow diagram show how, or in the form of pseudocode demonstrate. The secret to success, as with most things, will be practice. The more you practice writing algorithms,
Okay, so again, have a little look at that and look at the features of the pseudocode and the flowchart, and I would like you to have a go now yourself. Okay, 2 more minutes left. So what is the differences between pseudocode and flowchart? If you write it down on paper, then by all means write it down on paper. If you want to look at using obviously OneNote, then by all means create the table and look at the differences between a pseudocode and flowchart. Okay, 1 more minute left. Okay, so I'm going to start with pseudocode. It is text-based. Um, it is classed as an algorithm, but it is deemed as very close to coding syntax. So in other words, it looks like code, but it actually isn't. It can be written um, in various ways. So an example of this might be you might use VB oriented. You might also want to use, say, Python, for instance. You might also just want to use bullet points. Okay, these can be a wide range of um, pseudocode. Okay, and another one might be could be deemed um, a bit more complex compared to flowcharts. Okay. Then we move on to flowcharts. Now, flowcharts is basically it is shape driven with various shapes meaning different things. Then when you look at it, it's shown as a diagram. So it is actually shown as a diagram for people to sort of follow the lines. Program flow is easy to read as you can follow the arrows. So when you know what's coming up next, you literally just follow the arrows. I've actually looked at other some other people's flow charts, and they haven't actually added any arrows in, so you don't know kind of what way you're going. Okay, but can lack detail at times, depending on who is writing the flowchart. So sometimes you might not get the amount of detail that you need compared to pseudocode. Okay. Now, when we move on further, then we'll look at this. Now, we can actually see here that there is basically is a pseudocode, a flowchart that we're going to actually convert into a piece of pseudocode. Really easy, really straightforward. So, I'm now going to give you, let's just say 3 minutes. Then 3 minutes, I would like you to create a piece of pseudocode that will mirror up with this flowchart. Once I've done that, after the 3 minutes, I will write it, and then we can compare answers to see if you guys are on the right kind of lines. Okay? So again, look at that flowchart and convert it into pseudocode. Okay, so that's 1 minute gone, 2 minutes left. Okay, 1 more minute left. Oops. Okay, so here we go. I'm going to have a go now myself. Okay, so again in pseudocode, we don't necessarily need to say start or whatever. So we're going to put if raining equals 2, yes, then we're going to do all of this thing. Okay, yeah, so we're going to do all of this thing. So we're going to say find umbrella. And then in here say is if umbrella equals to found. Then we're going to do all of this. So we will do, we're going to indent, and then we're going to say bring umbrella. Okay, here I'm going to put in an else. Let's just change. I need to get rid of these bullet points because it's messing up my. That's better. That's got to go back one. Move that in one. Move that in one. That can go in there. Else. Keep finding umbrella. And then here, just got to go back one. And I'll just say else. Don't bring umbrella. Okay. So there is just a little rough guide, and that is basically using a nested if statement because we've got an if, which is raining. Then we find umbrella, is it found? So don't forget, it's using the actual shapes. We know diamond is an if statement. We know a rectangle is obviously a process, and we know the start and end, which are sort of rounded circles. Okay. So that is what I've got. Okay, and then that is all you needed to have. Okay, we could have obviously put in there some kind of validation to check to make sure they put yes and no. We could obviously put some while loops in there just to keep looping round. So again, that is basically where we are. So if you wanted to, you could have put here, could have put there a while, a while true. And then you could have indented all of that inside of that while true loop. Okay. So again, that should have went in one. Sorry guys, this should all go out one. Let's do it like this. That's got to go out one as well. There you go. So that is, and then that then will cater for that loop around. Because that, once it gets to there, it'll loop around. Once it gets to there, it'll keep looping around. Okay. So our next one. Our next one looks something like this. Okay, so worked examples. So this is where now we're going to have a go. This is on 2018 GCSE paper. This was. So again, we're going to branch the differences between GCSE algorithms and A-level algorithms as well. Now, I'm going to read it out, and then we need to think about what kind of things we need to write as this algorithm. Okay. So, OCR Town are holding an election with 3 candidates, A, B, and C. Electronic voting booth will be used to allow people to vote. So it's a bit like when the general election's on. There'll just be a little booth, you go in, write your number, and then that's it. Okay. So allow voters, so write an algorithm that, I want to do the following. Allow voters to enter A, B, or C. Keep track of how many times are actually our voters have been voted for. As soon as one person has finished voting, allow the next person to vote. At any point, allows the officials to type end it will calculate it all up together. Okay, it will calculate it all up together. Now, again, this was quite a while ago now. Um, so what I'd like you now to do yourself is have a go and see if you guys can come up with the solution to this. Okay, I will do the solution with you. Um, so again, I would like you now to have a go yourself. I would like you to have a go yourself at creating this algorithm. Okay, think about it. Look at there's probably a loop in there at some point. There is also you need to initialize A, B, or C. They're going to start at 0. So when we initialize something, we're going to initialize at the top. We're going to keep track. So we need to obviously have some kind of variable for A, B, and C that we'll keep adding to each time. So have a go yourself. I'm going to give you 5 minutes on that. This is actually a 6-mark answer. So think about where your 6 marks might come from. Okay. What I'll do is I'll put a little bit of music on the background so then we can get and then we can have a go at creating this. Okay, guys, 3 minutes left. Okay, guys, 2 more minutes left. One more minute left. Okay, so here we go with the answers, or the answer to this. Okay, so first things first is we've got to initialize the actual, we're going to set up the variables basically. Okay, so I'm going to call it a vote. I'm going to call it a underscore vote equals to 0. I'm going to put b underscore vote equals to 0, and I'm going to put c underscore vote. This will equal to 0 as well. Okay, so I have started off now with the initialization of it. The next one on this is we now need to, like it says there, as soon as one person has finished voting, allow the next person to vote. Okay, so I'm literally just going to put that into a while true loop. While true. Oh, okay, and now I'm going to indent one. Okay, and I'm going to put in vote. I don't want that capital. Vote equals to input. Vote A, B, or C. If vote, lowercase if vote equals to, I'm going to put in A, indent one again. I'm going to put in A underscore vote equals to A underscore vote plus 1. Okay, and then we do the same. Elif vote equals to B. Done it again, haven't I? Bullet points. Cool. So Elif that equals to that. Indent 1. that can be indented one as well, like that. I'm going to put B underscore vote equals to B underscore vote plus 1. Elif vote equals to C. And then it's going to be C underscore vote equals to C underscore vote plus 1. So now all of a sudden that now will loop around. Okay. I am now going to put in Elif vote. All right. Type end for the result. If vote equals to end, I now have got to do the following. So it's asking me to print out the number of votes per one. So all I've got to do now is I've got to print a underscore vote. I've got to print B underscore vote, and I've got to print C underscore vote as well. Okay. But then if you notice, it says, which will print out the number of votes for each candidate and the total of votes overall. So I'm going to put in print. In fact, I'm going to put total equals to, and then I'll put in A underscore vote plus B underscore vote plus C underscore vote. And then there, I'll just print out total. Okay. And that is basically how you would answer that to potentially then get the full marks. Okay. You would get a mark for A, B, and C, get a mark for your while true, get a mark for your input, so there's 3 marks already. You get 4 marks for this. You get your 5th mark for adding in all them, and your 6th mark for that. Okay. Now, challenge time. Challenge time. We're now going to go through this. This is the A-level style question. So as you can see, it's a lot more wordy. You've got to abstract all the key bits of information. So I'm going to read that out, and then I'm going to show you the mark scheme. You can then make a note of the mark scheme, and then I would like you to create this as an algorithm. Okay. This is going to be your challenge that's going to be emailed to me. Okay. So here we go. A car has a feature in its engine management system that is intended to save fuel and emissions produced when the car is waiting at a traffic light or in a traffic jam. The default option is that if the gears are disengaged and the car is not moving, the engine is switched off. There is a display on the dashboard that indicates when the engine has been switched off in this way. However, sometimes it is necessary to keep the engine running when the car is stationary in order to provide electric power to charge the battery, run the heaters, run the air conditioning system, or keep the lights on. This, in turn, is affected by the external and internal temperatures, the settings chosen by the driver, and the intensity of the light outside. Okay, so there's a lot of if statements in there. There's a lot of understanding. Well, I might have to loop that bit round, or I might have to loop this bit round. Again, these are all if statements. Okay, and don't be too disheartened when it comes to understanding this. It's just understanding what order to put them in. Okay, to make sure it's got a logical reasoning behind it. Now, when I go through now the mark scheme, The mark scheme looks something like this. Uses an endless loop while ignition is turned on. So in other words, when the ignition is turned on, this has got to keep happening. Okay? And if you notice there's a load of if statements. So it says, if external temperature is less than target, then override. Okay, so in other words, if the external temperature is below a certain point, then it'll override it and just keep it running. If the external light, so for instance, if it is a daytime or nighttime, whatever you want it to do, then override whatever you were going to do. In other words, to turn the engine off. If internal temperature is set to temperature and the heater is on, then override. So in other words, if the internal temperature is below the certain set temperature, so just to let you know how car works, you'll have something called climate control, and the driver can actually set it to a certain temperature. If it is below that certain temperature, the heating and the aircon will still be on. Up until, and it works like a thermostat, up until the temperature is on or above, that is when the heating then will turn off. Okay. The next one says if internal temperature is greater than the temperature and aircon is on, then override. If the battery output is less than a target, in other words, if the battery is running low on power, then it needs to still be on. If wheels are not moving and gears are not engaged, then not override, then stop the engine. Okay? So in other words, if we are at a standstill and the gears are out, then you can then stop the engine. If the overriding engine is not running, then obviously start the engine. Okay? So again, there's a lot of if statements in there. You've got to think about what kind of order have we got to put them in, how can I do this, where can I go with this, all that kind of stuff. Now, again, I'm going to upload this to YouTube. So if you've missed that slide, then obviously you guys can get that at a later date. Now, your challenge. I would like you to put that together. So I've read you through the actual scenario. I've read you through the actual mark scheme. What I'd like you to do now is to create that pseudocode, whether it's in a Word document. If you're on paper, then obviously write it on paper, take a picture of it and send it to me via email. If you are doing it in a Word document or a PowerPoint, send me that. If you're doing it in your OneNote, copy and paste that from your OneNote into an email to send to me, and I will actually give you feedback on it. Okay? Now, that is lesson up. That's 45 minutes, so we've done really well there so far. What I am now going to do, I'm now just going to turn off